This lecture today we are going to look at missing data. Again, missing data is a result of various pieces of information that are missed by the employee, clerk, or while entering some of the information gets overlooked and not got filled into the database. So these are very common scenarios that can happen with your data, and you always indeed need to clear out that information. That cleared information has to be put in perfectly okay in your database. One thing that you will realize that with the data, if your data is set is very large, you can take out those rows which has missing data. But you have to be careful. If you have a lot of data, like millions of rows, I would say maybe 1% of the data won't matter that you'll take out. The other thing that if you take out the data, or if you don't put the information, let's say the salary, if you're looking out at this data.csv file at the corner, you're seeing that salary has been entered for most of the employees, but one employee is missing that salary. He's from Germany. And then we are also looking at the age column, and in the age column, age is missing for that person. So one thing that you need to take care of it. If you don't enter that information, this information will be will not be sometimes ignored. You will have to explicitly mention that ignore those rows that have the missing data, but that induces a lot of work. Better is either put a zero, but the problem with putting with zero is that it will skew your data a lot, because if you put a zero in a salary column, uh, most of the employees are having the salary in thousands. And then if you remove that and put a zero instead of a null value or a space or empty value, I would not say space, empty or a null value, then it will actually be, if you're looking at running any statistics on it, statistics on the data, it will average out, will eventually will becoming the low averaged value. So you don't want to be putting zero. There are two ways to tackle it. As I mentioned, one is to take out those rows completely so that it will not uh, affect the average or median of those values. Or you can put the average value. You can find out the sum of all the average values of these here's the salaries and all that, and then put it in this as a common uh, average value here. And same thing that you will do with the age. That is the best you can do if you want to retain that data. And if you don't want to retain that data, 1% of, however, you 1% of the data can be ignored. However, you don't want to be ignoring too much of the data, let's say 2 or 3% of the data, because if you are going to do that, then you are losing the essence of the analysis that you wanted to run on that data. So you have to make sure that you are dealing it properly. We are going to deal it here in terms of adding the average values, and that is the best way to keep this row not getting deleted, and at least have some information rather than have no information in that. So that is a little bit of background on it by average of all these salaries. So let's jump into it. We are going to add a new library now. If you don't know that library, that will be called as a scikit-learn library that is available in Google Colab and actually is available in Python, which we are going to import here. We are going to basically learning 3 to 4 lines of code here to take care of the missing data with the help of the average value. And that is where uh, Python becomes so much more powerful, where you don't have to run loops and you don't have to find the data or do anything with it. It will automatically deal with that missing piece of information. So let's look at that. We'll start to import a new library, which is scikit-learn library, and in there will be a class that we will be importing called simple imputer. When I will write the code, you will look at that. What are the lines of code that I'm going to be including? And as we can see, if I run this data as it stands right now, after importing, we have already covered these two in the last two lectures. Uh, and as you can see, there is NaN here and NaN here for the age. So it has been in the data frame. We have this data um, that has a missing value showing up as NaN. And we don't want that. So we are going to import the scikit-learn library. From scikit-learn library, we are going to use the simple imputer class scikit-learn dot or sklearn dot import simple imputer. And after that, the object oriented analysis, the object oriented variable that we are going to create, or object oriented object that we are going to create, the name of that object is called imputer. And we are going to create a simple imputer, bracket open, bracket close, but we are going to pass an overloaded parameters or overloaded arguments to that simple imputer class, saying that I want to create an imputer object with the simple imputer method, which includes uh, two parameters. One is what we are going to address. We are going to address missing values or empty values. So we are going to say missing underscore values is equals to np.nan. Now you might be asking, what is this missing underscore values is that it is a parameter or the argument, and those who know Java or Python already know that this is how you will be mentioning your parameters. So I'm explicitly mentioning my parameters, and don't worry, missing underscore values is actually the property of this simple imputer method, which accepts a parameter name missing underscore values. So simple imputer class already knows what is missing underscore values is. It is the predefined variable that simple imputer class already knows. And you are saying that, hey, simple imputer, you know the missing values variable. I want to look out for those values which are showing up as an empty value. The next parameter that you are going to give it is the strategy. What is the strategy that you wanted to do with that missing data? You are inducting the mean or the average value to it. So that's how we are going to deal with. There are some other strategies that are available, but that's that's up for you to look at the documentation of scikit-learn imputer if you are going to deal with it. As I said, I'm going to keep it really simple. So I have just dealing with saying that for the missing values data, which is showing up as NaN, the strategy that I want to include to fix that missing data, I'm going to use the mean. And then you'll say imputer.fit. Now imputer.fit requires which columns are the problematic columns. So this is important part that we don't want to be including the columns with the textual data in it, the text or string data. We are just should be dealing with the data that has a numerical value to it. Missing values is for the numerical values. That is the rule that I wanted to mention it here. If you include country here, it will not know. And let's say if there's some person that is missing a country, uh, taking care of missing data won't help because it will not simply put out the country for you and you will get some errors. So don't even think about including the simple imputer on the text based data. You will be dealing with it on just the numerical data. Um, and as you can see, age and salaries are the numerical data that we want to fix. Most importantly, out of these two columns, salary is the important one. then the age. But let's keep moving forward. Imputer object dot fit method, if you look at it here properly, dot fit method requires the data frame that says I want to include all the rows starting from column number 1 ending at column number 2. The reason I say column number 2, even though the number is written as 3, is that remember in Python, you have to stop this at the one level higher and it will stop one level lower for you. So if you count this 0, 1 and 2, but you have to give 3, although 3 is not included because this is the dependent variable and this is actually is being taken care in y. But where is 3? 3 is nowhere because when we split it up, split it the data, we have 0, 1 and 2. Where is 3? But problem with not the problem, I would say, just the intuition in Python is that you have to include all the columns, then you include one number higher than that. And that's the easiest way I can say. Then in the next line, line number 4, which is the last line of this code, I would say, is that you are going to say, hey, imputer, please transform based on this strategy of the missing data. And these are the rows that I want to include, and these are the columns that I want to include. So it actually starts at number 1, which is 0 and number 1. 1 is here and 2. But because 3 is given, it will stop less than 3, which is 2. And this is as simple as it can get. If you give 2 here, it will not include the salary column. So that's the one thing that you need to take care about. And now it's time for us to test our data. So I also added the print statement just below it. So how I would run it, I will run the cell. And then after run this cell, it will run all these 4 lines and it will do the transformation. And remember, once the transformation is done, we don't need to be changing the country column. We don't need to be changing any the country column. We are only changing back and fitting just these 2 columns, age and salary. So when we are writing back, we have to actually mention that once you are done the transformation, please write it back to the columns which I am mentioning. And indeed, those are the columns are age and salary. That's why I am writing it back to those columns, and it is being written back to those. And as you are seeing here, NaN is now, here you go, is replaced by the average of the values of all the salaries. And again, as you can see, the age is also replaced by the average of the values of all the ages. Obviously, it's a little bit uh, with the decimal points, which I don't want, but it has done the job for me. I'm not too much worried about extra decimal points. So this is my transformation of data of the missing value. And believe me, you will see a lot of data and encounter a lot of databases where the data has been missing out of certain values, and you want to be dealing with that. But the more data you have, the millions and billions of data, you can fix that data with that. But if you have thousands of data, it's better just to get rid of those rows because the impact on the final computation will be lots. All right, so that's all I wanted to mention today.